Soldering is a skill that electrical engineering students and practicing engineers should know. It's fairly easy to learn and you can become proficient very quickly, and it's also fun. So let's take a look at some soldering skills. This is the Weller soldering iron that we supply in the labs. It's a professional quality iron used in industry. Only turn it on when you're ready to use it. It only takes 2 to 3 minutes for the tip to warm up and come to temperature. If you turn it on too soon, the tip will oxidize and you'll get a very short life out of it. In your lab kit, we supply you with a barrel nut, which is this part right here, and a soldering iron tip. The temperature on these soldering irons is controlled by a magnetic tip. The back side of this tip is a magnetic region, and this one's stamped with a 7, and the 7 means 700 degrees. And the way these irons work is that this tip is heated up, and its rated temperature is 700 degrees. It loses its magnetism, and a switch inside the barrel here opens, letting the tip cool. When the tip cools enough, then the switch closes again and heats the tip up. And this is the way that the temperature is controlled on the soldering iron. So sometimes you'll hear a slight ticking noise coming from the barrel. That's the switch inside opening and closing, maintaining the temperature at the rated temperature of the tip. The sponge on the soldering iron holder is for cleaning the tip. You should keep it wet, not soaked, but pretty damp. And the sponge is oriented so that these grooves are in line with how the iron's put in and out of the holder. And the reason for this is when we want to clean the tip, we drag the tip through a groove and twirl it, and the tip of the soldering iron comes out nice and clean. Once it's clean, I put just a little more solder on it to keep the tip cleaned, and if I wanted to clean it again, let's say, I just draw it through quickly. Don't linger in there in the sponge, because you'll cool the tip too much and it'll be hard to make a solder joint. Now this isn't a new tip, but when you do put a new soldering iron tip in your iron, it's really imperative that you tin it. And tinning is just placing really just a whole bunch of solder on that tip and letting it soak in. The tips are iron plated, and what you want to do is get a nice coating of solder on there, maybe clean it off a little, put a little more on. And what we're doing is providing a nice coating on the tip to prevent it from oxidizing. If you leave this tip uncovered with solder for just a few minutes, that tip begins to oxidize and the life of the tip is greatly shortened. So when you're ready to make a solder joint, here's what you do. Take your iron out, clean the tip off, put just a little touch of solder on it. So this protects the tip while we're getting ready to solder, and it also provides more efficient heat transfer to the parts we're going to solder. I can take my component, and in this case I have a pad that has lots of solder on it, and I just press down into that pad till I see the solder melt. Notice I'm using the side of the tip to get a more effective heat transfer. Now if I need to, when I'm making the joint, I can add some extra solder. This joint happened to have plenty on it. But I can add some more solder to the joint. And what I want to do is just fill in the voids. Don't want to make a huge mound of solder. I can even touch it up again, but just to fill the voids between the different components. You want to heat the leads and make sure the solder adheres to them. What we don't want to do is to add solder on the tip and then try to smear it on like it's glue, because we're not gluing, we're making a solder joint. So the iron, the heat from the iron goes to the metal pieces, and then we apply solder to those pieces to make the good joint. When we're done, well, before we're done actually, hold still until you see that the solder has solidified. Don't move it while it's still molten, or you get a crystalline structure in the solder and it's a bad solder joint. And once you're done, Don't clean the tip, just put it back because it has solder left on it now, and I can just put the iron back where it was. Here's another picture of that. Take the iron out, quick cleaning, a little bit of tinning, apply the solder to the joint, hold it still, see that it's solidified, put the iron back. All done in just a couple of seconds. So this board is tinned, that's why it's shiny there. It makes it easy to solder to. And one of the ways we can make a connection easily on these big pad boards, that's what I call them, is to first flood the pad with solder. Then I can also pick my component up and tin the wire itself. This just makes the wire a lot easier to solder onto the pad. Now I can take the lead, push it into the molten solder. See what a shiny surface the solder has? That's one way I know that it's a good joint. Sometimes if you're bored after you've used it for many different experiments, and we can use these boards over and over and over, they get a lot of solder built up on it. Now here's the technique you can use. You need to be really careful when you do this though, to remove that extra solder. Is to heat it. Again, I'm using the side of the tip, get it good and hot, and wrap it against the tabletop. The pad comes nice and clean. Solder blobs hit here on some other surface, and by the way, that 700-degree ball of solder goes right through a $400 Gore-Tex jacket like a bullet. Also, if this goes in your eye, it's bad news, so be very careful using this technique. Sometimes we want to put a component in with really short leads. The problem is with that, really hard to pick up and really hard to hold and solder, especially without burning your fingers. So if you want it really short like this, only cut one side of the lead short. I'm going to take that lead and tin it. Then I can put it on my board and I have a little handle to hold it. And there's no way that's going to burn me. Then I can just cut the other lead to whatever length I want. And I have something that holds it for me now, and I can solder the other end down. I'll even use my diagonal cutters as a little forming tool here. Push it down to the pad, and I can solder the other end on. Nice and easy. Sometimes we want to tin a stranded wire. This is a piece of coax, and the braid is of course a stranded wire, and so is a center conductor, and we want to tin those and make them like, at least where we would connect to them, a solid conductor. And here I would touch the back of the solder and the tip, and it just flows into the tip. And the braid, the same way, it'll take a little more solder for the braid, and you'll see that braid just soak the solder up. I can run the iron up and down a little bit, and there I have a nicely tinned lead. One of the problems you may run into is that your tip gets dirty, and when that soldering iron tip gets dirty, you just really can't do a good job soldering. So what you might be tempted to do is to take a knife to it and scrape it, or a file or sandpaper. Don't do that. That will ruin the tip. The iron coating on it's very thin, and that would destroy it almost instantly. Another problem is sometimes you might think you can solder aluminum. Don't even try. It's not going to work. It may even look like it works, but without special solder, that doesn't work. Also, if you have some old components whose leads are oxidized, they'll be very hard to solder. One thing you can do is scrape those and maybe apply a little solder and tin them, and then it works. One other problem is often, or not often really, but sometimes the heater inside here will malfunction and the iron will stay in the on condition. The tip will almost become red hot. You may pick up your iron and find that it's so hot you can't handle it, or that when you touch the solder to the tip, instead of just gently smoking like that, it just sizzles. Well, that usually means that this heater has malfunctioned. If that's happened, notify your TA. We need to get you a new soldering element.